we have a couple people out. Okay, so first one we want to do is number 9. So even though I told you there's only 20 problems on the final, there's actually 24 problems that I want to go over, but that's because 4 of those, I feel like we need to hit twice because they bother some people. So this is one of those that we're going to hit twice because I feel like it bothers some people. So, okay, all we want to know is what quadrant are we in? So if you remember the little thing we did here, this tells you who's positive. So everybody's positive in first. Okay, all students. This is sine and his little reciprocal, right? He's positive here. Okay, tan is positive here. Cosine is positive here. All right, so now we want to know what quadrant is tangent positive in? All right, well, everybody's positive here and tangent's positive here. Everybody agree with that? Okay, that narrowed it down. Okay, so it can't be quadrant 2, so no A. Can't be quadrant 4, no D. Okay, now we want sine to be negative. Everybody see that? So tangent is positive, sine is negative. So here, everybody's positive. It can't be that one. So what are we left with? Quadrant 3, and that's our answer. Is that okay? Everybody's good on that? Okay. All right, easy enough, but sometimes it's those little easy ones that get you. Okay. Ish, you're like an old lady in church with a peppermint. Just hold that open. They take all day to mess with it. Okay. All right. Now we're on to 15. Okay, 15 is a little strange, and it's a word problem, and you're going to have to draw the picture, and we got the shadow and, you know, the whole deal. So here we go. Okay, I'm going to draw a little picture down here at the bottom. So it starts out pretty easy. All right, here's the ground, and we have a building. Okay, here's our building. And the building is 180 feet tall. Okay, and it casts a 70-foot long shadow. Where's the shadow? On the ground. The shadow's on the ground. So here's my 70-foot shadow. Okay, and a person, I think I drew my shadow too long. Okay, so a person is standing down here. Here's my person, ta-da, at the end of the shadow. Everybody with me on that? So if you're not good at drawing pictures, by the time we're done, you may want to draw this picture, right? So that when you get to this problem, you got a picture. Okay, all right, so that's easy enough. Now it says that the person is looking up at the top of the building. Okay, so we're talking about angle of elevation up here to the top of the building. So that would be pretty easy if his eyeballs were down here on his toes, because we just start down here and go, and we got a beautiful little angle and we're good to go. But this tells us, that kind of a short person, maybe they're a kid, right? It says, assume the person's eyes are 4 feet above ground level. So I'm not drawing my angle from his feet. I'm drawing my angle from his eyeballs, right? So this is going to be my triangle right here. Does that make sense? Okay. Now, I have to be careful here. It still has a base of 70, right? That's going to stay the same for this triangle. But is this side over here still going to be 80? 180, I mean? No, this is not going to be 180. I guess maybe I should have said like this whole thing here is 180. Okay, so we said the little dude's eyeballs are 4 feet from the ground. So if this is 4 feet, then what's the side of this little right triangle? It's going to be 176, right? Because it's 180 minus the 4. Okay, so the triangle we're actually solving for, and here's our theta that we're looking for, that's our angle of elevation, is here. So this stays 70 because that's this length. okay? But this side is no longer 180. If you leave it 180, that will be a choice, okay? You've got to reduce this side to 176. That's what this piece of information tells you, is to reduce that right side. Okay, so now we want theta. All right, well, that's easy enough. So if we want theta and we have opposite and we have adjacent, because we're going to pretend it's a super straight building, what function gives us opposite and adjacent? Tan. Okay, tan theta equals opposite over adjacent. Okay, so we're going to have tan theta, okay, equals 176 over 70. Everybody agree with that? And then how do I find theta if I have the right side? What am I going to do in my calculator? Inverse. So I'm going to take the inverse tan of 176 over 70. And that's going to give me theta. Now, look at your answer choices. Should I be in degree mode or radian mode? Degree. Okay, so here's our calculator. I'm going to go down here to degree mode. And I'm going to do second tan, 176 divided by 70, and I get 68.31. It'll depend on your answer choices and the problem, but no, I don't think so. I think you have to switch back on some. Okay, so is everybody okay on that one? So if you're going to need to draw this picture on your card, then you need to make a note for yourself. Otherwise, just remember, however tall the building is, subtract from how tall the little dude's sides are. Okay, I think they're 4. And there you go. Everybody okay on that one? I know you guys don't like word problems. Okay. All right, let's look at 67 then. Okay. They give you absolutely no room on this stupid review. All right, here we go. Okay, we have ourselves a triangle. So, and the only other one we're going to do on this page is 75. So if you need to write somewhere on it, you're fine. You can do that. Okay, so we're going to draw a triangle. The directions are kind of up here above 65. They say solve the triangle, round your lengths to the nearest tenth, your angles to the nearest degree. Okay, so here we go. All right, I'm just going to do my standard labeling since it doesn't tell me anything else. And I'm going to do ABC like that because I think that's how I did all of them. I'm not on the right page. Yeah, okay. So here we go. I know B is 14 degrees. I know C is 104 degrees. And I know little b is 50. Okay, there we go. All right, well, I could go ahead and find angle A. How would I find angle A if I have the other two angles? They're going to add up to be 180, right? They always add up to. Now, I didn't put that on the board. If that's something that you want to write or keep as a formula, you might want to jot that down if you're prone to forgetting that. But all angles of a triangle add up to be 180. So angle A is going to be 180 minus 104 minus 14. And I got 62 degrees for angle A. Okay. All right. Okay, now is going to be what you said, Ish. So now that I have that done, really there's only two choices. There's the law of sines and there's the law of cosines. And remember, you always want to go law of sines if you can. So can I do law of sines with this triangle? Yeah, because I have all the information I need for B and I have one piece of information for the others. So I'm going to use law of sines for both sides for the others, okay? All right, so here we go. Let's just solve side A first since we're here. All right, if I want A, he goes on top, right? And then the sine of his angle goes on the bottom. You may not remember law of sines. You may have forgotten that immediately, but it's, you know, they make themselves a little ratio, the side and its angle. Okay, and then since I have B, side B on top, sine of 14 degrees on the bottom. There we go. Okay, remember, we're going to multiply these two together and we're going to divide by sine of 14. And these are all in degrees and I'm in degree mode. Ask yourself that before every question. So I'm going to have 50 times the sine of 62 divided by the sine of 14. And I came up with 182.49. Does that sound okay? Okay. A equals 142. Nope, I lied. 182.49. Okay, there we go. All right, we have one more to get. Now we want C. Okay, so side C over the sine of 104 equals, I'm going to stay with my B's, side B over the sine of 14. Okay. I'm going to multiply these two together. So I'm going to get 50 times the sine of 104 divided by the sine of 14. And I get 200.54. There we go. Okay. All right, I did not follow my information at all, my directions. I guess I was supposed to round to the nearest 10th. Oh well. Okay, so everybody remember law of sines. Are you comfortable with law of sines? Okay. All righty. Where does that take us? 75 then. Okay, so this was the last test. Okay, this is given the vectors. Okay. Oh, here we are. Sorry. Write the vector in terms of I and j. Okay, so we're going to have I and j in our answer. It gives us the magnitude. Remember, that's R. This is R. R is 7. And it gives us theta. Okay, so it's kind of way down in here. I don't know if everybody can see that. I don't know if you can see it somewhere. Maybe you can. But right in here, okay, here's what I did. I wrote x equals R cosine theta, y equals R sine theta. And then I kind of was trying to indicate that's how you get your x and your j. I mean, your I and your j. So that little box is going to be what you want for this. Okay, that's really your only chapter 9 problem, I think, is that one. There's nothing else. Okay. All right. So in order to get my I component, which is x, I'm going to do R cosine theta. Okay. And then when I'm ready to get my j component, I'm going to do R sine theta. And there we go. Now I'm going to need my unit circle. Okay, my theta is 225. So here's 225. So both the cosine of 225 and the sine of 225 are both negative root of 2 over 2. Everybody see that? So that's what we're going to replace them with. Okay, so I'm going to have 7 times negative root of 2 over 2. And 7 times negative root of 2 over 2. Okay, well, you're going to have the same component for each. So we're going to end up with vector v equals negative 7 root of 2 over 2i minus 7 root of 2 over 2j. And that's going to be my answer. Okay. And that's how you're going to get it. Does that look all right? Okay. Okay. And then, would you believe that the study guide that the department gave you ended with number 94? And I looked at that thing and I was like, great, there are 4 problems off of there that pertain to the final. And the other 16 problems on the final are not even covered on that stupid thing. So then I filled in and made you one, starting on page 95. So that's why the thing is so thick, because then I came in the picture. So if you flip on over here to 97, then you'll start having some room because I spaced out what I stuck on the end. Okay, here we go. Huh? You don't remember how to do anything at all. Okay, here we go. So, well, luckily it's multiple choice, right? So that's kind of good. All right, hello. Okay, there's study guides in the back. All right, we're going to complete the identity. So we see 2 parentheses in the top. What do you think we're going to do first? Let's FOIL. Okay, that was Ish for FOIL. Ish said FOIL. Okay, all right. So we're going to do, what's cotangent x times cotangent x? Close, cotangent squared x. Okay, and then we're going to have plus cotangent x plus cotangent x plus 1. And then finally a minus cosecant squared x on the end. And then on the bottom, cotangent x. Okay, sound good? All right. Really, the only thing I can clean up on the top is I can add these 2 middle cotangent x's together. All right, so I'm going to copy over cotangent squared x. What's cotangent x plus cotangent x? 2 cotangent x. Good. And then I have plus 1 minus cosecant squared x. And then in the bottom, a cotangent x. Okay, what could I possibly do with this? Because it's crazy. All right, remember when you start seeing squared functions and ones involved, you're going to look at Pythagorean. So I wrote you the two Pythagoreans you're going to need right here. Now, obviously, we're not going to need this one at this point, but we could use this one, right? So if you see a 1 plus cotangent squared x, even if they're not sitting next to each other, when you see that, we can replace it with cosecant squared x. So I see 1 plus cotangent squared x. Now I know they're not sitting together, so it's kind of a stretch for you to see it, but you'll just have to look for that. I'm going to replace these 2 terms with cosecant squared x. Everybody see that? I took this one and this one. Okay, now I still have plus 2 cotangent x minus cosecant squared x all over cotangent x. Is everybody okay with that substitution? That's the key. And then it really falls apart on its own because look what cancels. 2 guys on the end. Boom, they go away. I've got 2 cotangent x over 1 cotangent x. What goes away now? The cotangent x. What are we left with? A nice 2. Okay, so FOIL it out. I think that's pretty intuitive. The big step is remember to use that Pythagorean. That's what's going to really make it kind of fall apart and give you what you want, which would be a nice whole number. Okay. All right. Let's see. Let's look at 98. Now I know we already did one like 98. It was number 9. But this really, you know, it's one of those that's so easy, but it really gets some of you guys. So I just felt like we needed to talk about it again. So when it starts talking about quadrants, right, we're going to do this and we're going to say everybody's positive here. Signs positive here. Remember, all students text constantly or all students talk constantly or whatever you want, whatever you do all the time there. Okay. Hands positive here. Cosines positive there. Okay. So now this tells us, this is interesting, tangent is what? Positive or negative? Negative. So it's going to kind of be the opposite of this. I don't want to know where everyone's positive, and I don't want to know where tangent's positive. Okay, we kind of did the opposite. All right, now that leaves us with 2. Okay, now is sine going to be positive or negative? Negative. Sine's also negative. Okay, so which quadrant are we going to cross through? The one where sine's positive. And the only one left then would be quad 4. And you know they're going to write it like this with the Roman numeral, right? And you know that's going to be the quadrant. Okay, so sometimes you're gonna want to pick who's positive, and sometimes you're gonna want to pick who's negative. So just make sure you can do it either way. All right, let's look at 99. Okay, 99 gives you sine, and it tells you what quadrant you're in. Okay, now that's purely to let you know who's positive and who's negative as far as x and y goes, right? And it wants you to find secant. In my experience, half of the class is going to pick the choice that says -3 halves, because that's going to be a choice. Why would you pick -3 halves? What mistake would that be? You think these are reciprocals, right? Cosecant would be -3 halves, and it's going to be a choice. And so half the class picks it every single time, but they're not giving you the reciprocal of sine. They're giving you a completely different function. So please, please, please slow down and really pay attention to that, okay? If you're one of those that's a little susceptible to that, make sure you put those first couple lines on your index card if you need it. Okay, so what this tells me, since this is sine, and we know that sine is y over r, right? This information is telling me that y equals -2, and it's telling me that r equals 3. Everybody agree with that? Okay. Now, what I'm going to need to find is x. Now, quadrant 3, is my x going to come out to be positive or negative in quadrant 3? Negative. So you may want to go ahead and throw that in before you forget that. Okay, so I'm going to need to find x. So if you kind of look in that Pythagorean area where I just was, that's to kind of remind you that r squared equals x squared plus y squared, right? You're going to go back to that kind of Pythagorean thing. Okay, so what I'm going to do here is I don't know x squared, but I know y, and I'm going to square it. And I know r, and I'm going to square it. So when I clean that up, I'm going to get x squared equals 5. I'm going to take the square root of each side, and I get square root of 5. But remember, we want it to be negative because we're quadrant 3. Okay, and that we know that because they told it to us. That's how we know that. Okay, now we want to find secant. Well, you can remember secant a couple of different ways. You can just find cosine, which is x over r, and then you can flip it. Or you can actually remember what secant is, that's your decision, which is going to be r over x. Okay, so you can either find cosine and flip it, or you can actually remember r over x. Either way, you're going to have 3 over negative root of 5, right? And then you're going to have to rationalize it. And you're going to end up with -3 root of 5 over 5. And there's your answer. I did not leave you enough room there, sorry. Okay, does that make sense? So it looks really easy. It looks like it's going to be as quick and easy as 98, but then you get into it and it kind of requires some thought. So just make sure you're able to identify what letters these are, okay? Who's going to be positive and negative? Use that r squared equals x squared plus y squared to find whatever letter you're missing. Know if it's positive or negative, and then plug it back in to get the other guy. Okay, does that sound all right? All right. Let's see. Okay, number 100, that sounds crazy, is another one of your word problems, okay? So you're not going to have any crazy airplanes or cruise ships or any of that nonsense, but you do have this. Okay, so you want to find the distance between two small towns, and you're going to use a measuring device called an EDM. I thought EDM was like electronic dance music or something. I don't even know what an EDM is. Okay, but it's going to be placed up here on a hill. Here's your EDM. Okay, and you can see both towns below. All right, so here's town one over here. Okay, and here's town two over here. Got it? Okay, and here's your little EDM up here. All right, the distance from the EDM to one of the towns is 4.9 miles, so just pick a side. The other distance is 5.2 miles. Okay, those are your two sides. Okay, the angle between these two lines, it says the two lines of sight is 64 degrees. That's this angle up here. Okay, then it wants to know the distance between the two towns. This is what you're trying to find, is the distance between the two towns. Okay, everybody got that? So you're trying to find that side of the triangle. So you have two sides and you have the angle between them, but you don't have this side. That's what you're looking for. Everybody okay with that? So if you need to draw that picture on your index card, you may want to go ahead and do that too. Okay, well, can we use law of sines? No, we can't, because we don't have all the information for one particular letter, and it's not a right triangle, and we don't have two angles, so we can't do 180 minus. So what are we left with? Law of cosines. Okay, so if we label it like this, here's little a, here's little b, and we're looking for little c. That's how I have your law of cosines written, is perfectly set up to do this problem. So I know there's 3 versions of law of cosines, but if you draw your picture like this and label it, you're set up, ready to go. So if you notice, I put it just like this. And you have everything you need to pop right in there. Everybody see that? Kind of down there on the right. Okay, so I'm going to have to find c squared and take the square root. So I'm going to have 5.2 squared plus 4.9 squared minus 2 times 5.2 times 4.9 times the cosine of 64. All right, I totally ran out of room. Okay, should have scooted over a tiny bit more. Okay, and then you're just going to put that right in your calculator. Am I going to be in radians or degrees? Degrees, yeah. So just remember, whatever they give you, that's what you want. So they're going to give you degrees for this dude. Okay, so I'm going to have 5.2 squared plus 4.9 squared minus 2 parentheses 5.2 parentheses 4.9 cosine 64. Just like that. Enter. Gives me 28.7, but now I need to take the square root. Let me warn you, 28.7 would be an answer choice. They're trying to trick you, right? So make sure you take the square root, and we end up with 5.36. Oh, it wanted it to the nearest tenth, 5.4 miles. Is that okay? Everybody get 5.4, or whoever did it? Okay, good. All right. Let's go. Okay. So you don't need to fill up your card with the other 2 choices. Just use that one law of cosines that I gave you. As long as you do the ABC like this, you're good to go. Okay. All right. And then we're ready for 101, which is all the way back to January. Okay. 101, okay, wants to know the period of this function. All right, so remember that to find the period, and I wrote this on the board, it's 2 pi over b, which is great and all, but how do you know what the heck is b? Okay, b is whatever is sitting here in front of x. Now, ideally, b is going to be out front of the parentheses. That's where b is supposed to be, but it really doesn't matter. You don't have to remove it in this case because you're not actually finding anything else. So b is just whatever is there. So what's my b in this case? 3. So my answer is going to be 2 pi over 3. Ta-da. Okay. That's it for that one. That's all you got to do. So just remember 2 pi over b, and b is whatever is sitting here in front of x. What if whatever was sitting there in front of x was a 2? What would my period be? Pi. Because 2 pi divided by 2 is just pi. Okay. All right. That skips us on down then to 104. Okay. Right here. All right. So we have some inverses we're dealing with. Okay. So, all right, we got to remember how to do these. Okay, because we're going to do 105 also, but 105 is super easy. It's just weird looking. Okay, so 104, we want to take the tangent of this particular inverse. So we're going to do this first. This is where we're looking. What this means is, what is the angle that makes that true, right? What is the angle where cosine is root of 2 over 2, okay? But because it's the inverse, we're limited to 2 quadrants to look that up. Does anybody remember where the inverse of cosine exists? 1 and 2. Remember, cosine's a crown, sine's on the side. Remember that? So cosine inverse is on the top. It's quadrant 1 and 2. Okay, so I go to my unit circle. I'm only allowed to be up here in the crown. So where in the crown is cosine equal to root of 2 over 2, positive root of 2 over 2? Just here, right? So you can either put 45 degrees or pi over 4 because it doesn't specify and it's going to all come out in the wash. So why don't we just use degrees because most of you are more comfortable with them anyway. Is that okay? Does everybody understand why it's 45 degrees? There isn't any other positive root of 2 over 2 up there. Okay, so the theta here is going to be 45 degrees. Okay, so now I take the tangent from the outside and I apply it to the 45 degrees. So we did what was inside and this became 45 degrees. So now the tan of 45, okay, is y over x or sine over cosine. What do we do for y over x? What would the tangent become? 1. And that's your answer. Okay, so just one little step at a time. Know what quadrants you're allowed to be in, and then just apply the outside one to it. Is that okay? Okay, sure. All right. Okay, let's look at 105. Okay, so 105 is a little strange. We've never done one of these. I mean, we kind of in a roundabout way did one like it, but not really. And we certainly didn't use the letter U. So this is going to be what I would consider to be new. And if it bothers you, it might be one that you want to put on your card. Okay. All right, we're going to do it the same way that we did up here. We're going to ignore tangent for a minute. Okay. And we're just going to look at this. All right. Well, the problem is I can't go to my unit circle and figure this out. I don't even really care what quadrant it is because U is just meant to be some random variable. If this problem were written in algebra, it would say X over 4. You're just solving for that. It's just not solving for it. It's a variable that you don't know and you're not ever going to know it. And you're going to find the answer in terms of U. Your answer is going to have U's in it. Okay. So what this tells me then, okay, is that cosine of some theta, which I don't know what my theta is U over 4. Okay. All right, so we're going to take it back to what does cosine actually equal? Cosine equals x over r. Okay, so now we're going to substitute in our letters and we're going to make x equal u and we're going to make r equal 4 and we're going to solve for y. So the first thing we did is we kind of set it up and we said, okay, this is what they equal. Second step, we're going to use our x squared plus y squared equals r squared. Okay, we're going to plug in what we know. X squared is now u squared. R squared is now 4 squared. So this is u squared plus y squared equals 16. And we're going to solve for y. Okay. Solve for y. So we're going to have y equals the square root of 16 minus u squared. Okay, all I did was solve for y. So I subtracted u squared and then I took the square root of it. That's all I did. I moved this over to here and I took the square root. Is that okay? We're going to leave it like that. We're going to leave it like that because it has the minus sign. Okay, we're going to leave it just like that. Okay. All right. And we don't have to put plus and minus like we normally would, because remember, we're on the crown and whichever quadrant we're in, y is still going to be positive. So we don't need the negative version. That's why we're only interested in the positive. Okay, so this is what my y equals. This is what my x equals. This is what my r equals. Now we're going to take it back to tangent. Step 3 is, now we're going to find tangent. Well, tangent equals y over x, right? And now we're just going to fill in what it is. We said y is this giant radical. And what is x? U. And that's going to be your answer. So that one's pretty different. That's probably what I would consider the hardest problem on the final. Okay, just because it's kind of wackadoo, right? So we're going to take this, cosine tells me x over r. So x is u, r is 4. Then I'm going to use Pythagorean and solve for y. Do my algebra, y is going to be this, and it's going to be the positive, because that's the only thing it's allowed to be. And then it's going to want the tangent, and so then you're just going to put in it just like that. Okay, y is what we just found, and then x is going to be u. Okay, does that sound okay? I can kind of create another one if we want to go through it and do it one more time. We want to try it with a different number just to check, or you think you're okay? What do you think? Is everybody okay? Are you just scared to make me poke and do another one? You know I'll do 4. Okay. All right. Okay. All right. You can privately email me and we'll do 4 together. You don't have to tell anyone. Okay. All right. 106. Okay. Let's see this dude here. Okay. So I don't really have the directions the way they're supposed to be. So let's write the directions, what it's going to say. It's going to say solve over the interval. And then it's going to give you a theta like this. Okay. That's what it's going to say. So I just want to make that clear. Okay. So we're going to solve for theta here. So I'm going to divide both sides by root of 2. Oh, I already wrote it there. Sorry, guys. I didn't need to do that. Never mind. Holcomb already wrote it. Okay. Sine 2 theta equals 1 over the square root of 2. Okay. Now we need to rationalize that. So let's fix that up. Okay. So what we really have is sine of 2 theta equals root of 2 over 2. Okay. Perfect. All right. Now, here's the problem. We got a 2 theta in here. Okay, well, we're going to kind of ignore it for just a second, right? this is that weird situation where instead of 2 answers, we come up with 4 answers. Remember that? That kind of strange problem everybody hated? Okay, so we're going to kind of ignore this for a second, and we're going to go to our unit circle, and we're going to figure out, okay, where does sine equal a positive root of 2 over 2? All right, so it's a positive root of 2 over 2 at pi over 4, and we know this is radians because that's the interval they give us. It's also a positive root of 2 over 2 at 3 pi over 4. Everybody agree with that? Okay, so we know it's going to be pi over 4, and we know it's going to be 3 pi over 4. That's what our 2 theta is going to be. Okay, now we aren't just looking at theta here. We're looking at 2 theta for the moment, which means that we're not just looking at 1 rotation. For the moment, we're looking at 2 rotations because we have a 2 theta. So I'm also going to take each of these and I'm going to add 2 theta to them. Well, if I add 2 theta, but I want a denominator of 4, I'm actually adding 8 pi over 4, sorry. Okay, I'm going to add 8 pi over 4. All right, well, if I add 8 pi over 4 to pi over 4, that's 9 pi over 4. Okay, and if I add 8 pi over 4 to 3 pi over 4, I get 11 pi over 4. Okay, so because this is 2 theta, I have to add 2 pi to each one of those, and you should have 4 answers. So first step is you're going to add or solve for sine of 2 theta. Second step, you're going to find where on the unit circle does sine equal a positive root of 2 over 2. But because there's a 2 theta, you're going to have to add 2 pi to each of these 2 in the beginning to get 4. All right, your third step is going to be, I don't actually want 2 theta, I just want theta. So now I'm going to divide everybody by 2. All right. Well, if you want to divide by 2, that's fine. You can also multiply by what? A half. And you're going to get pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8. And those are going to be your 4 answers. Okay. So we're going to solve for sine of 2 pi. Then we're going to find what 2 answers gives us positive root of 2 over 2 for sine. We're going to add 2 pi to both of those, which is like 8 pi over 4 in this case, because that's their denominator. We get 4 choices. Then we divide everybody by 2. Because these are fractions, it's the same as multiplying them by 1/2. All it does is change their denominator. Okay. All right. We're doing all the worst ones first today. How does that sound? Not too terrible? Yeah. This is terrible. Okay. I did? Oh. I guess the H is supposed to be an A. Is that the problem? Oh, Elizabeth, why don't you run up there? Yeah. Thank you.
So for the root of 2 over 2, where you put the theta equals pi over 4 and 2 pi over 4,
Mhm.
wherever it equals that?
Yes. Yeah. So if this were a negative root of 2 over 2, then I would have 5 pi over 4 and 7 pi over 4. Yeah. So the first 2 come right off of here.
Oh, and you said a y value because it's sine.
Exactly. Exactly. Okay, good. That's what you're supposed to be asking, not staring at my little mistakes up there. Okay. So yes, that's so on the unit circle that you're looking at y because it's sine. Good. Okay. Anybody else? Sound good? Okay. All right. And then I just added 2 pi to those 2 and then multiplied by half. All right, y'all have checked out. You checked out years ago. It's okay. All right, let's look at 107. Okay, you'll get a nice little right triangle like this, and we're going to label it. And you're supposed to solve it. Okay, it is a right triangle. Can you use law of sines? Sure. I don't know why you would, but knock yourself out. It's just stuff like that all the time. Okay. Could you use law of cosines? Sure. Knock yourself out. You know, if you want to just do it the longest, hardest way possible, you're going to get the right answer. Okay. But it is a right triangle. So we also have Pythagorean that we can use. All right. So how would I find angle B? What would the easiest way to find B be? Subtract. So I can do my 180 minus 90 minus 45, 40.5, or you can just do 90 minus 40.5, right? And I come up with 49.5. Okay, easy enough. All right. Okay. Now you can use law of sines. This is where you get stumped because you forget the easy stuff. If you want to, you have all your information for A and you can solve for B or C, or remember, you can use any of those trig functions over there because they all apply to right triangles. So for example here, okay, let's say that I am, let's say I'm sitting right here in 40.5, okay, this is me. I have my opposite, it's 4.3. And I want my adjacent, which, you know, is B. I can take the tangent, because that's my tangent, of 40.5 equals my opposite over my adjacent, and I can find it that way if I wanted to. Or I could sit here and say I have my opposite, I want my hypotenuse, and you could use sine, right? Or you could sit up here and do it the other way too. So you can use any trig function you want to find these sides. Okay, so I did kind of do it a weird way, but if I multiply both sides by B, I get B times tangent of 40.5. And then if I divide both sides by this, that's going to actually give me B. Or you can just switch places. We talked about how you can switch places with them, but I didn't know if you remembered that. So from this point, you can just flip-flop these dudes, right? And I can do 4.3 divided by 40.5 right from there. So 4.3 divided by tangent of 40.5, and I get B equals 5.0. Okay. And then once I have B, I can do A squared plus B squared equals C squared, and I can find my hypotenuse. So I can do 4.3 squared plus 5.0 squared equals C squared. And I came up with 6.6 equals C, if you do it that way. So you have a lot of choices. You don't have to do it the way that I did. You can do it any way you want to. But the point is, you can use all your trig functions if you want to, or you can stick with law of sines and it'll work. It always works. Okay. Is that okay with everybody? Anybody have a question on right triangle? All right. Okay, let's look at 108. Okay. Okay, so we have tan theta equals -8 over 15, and we are told we are in quadrant 4. Okay, we want to find sine 2 theta. Okay, so this is the second time you've seen sine 2 theta, and I don't want you to get them confused because this is a completely different problem. The first time, sine 2 theta, right, was a little different. See him? He was like this, and you were solving for theta, and you needed to find all 4. Okay? This situation where you have the quadrant in a different, you start out with a different situation with tan theta equaling that. this is the situation that you're gonna use this identity for that one. Sine 2 theta equals 2 sine theta cosine theta. Okay, so I'm actually gonna find 2 sine theta cosine theta instead. Because I started with something different. I have something different to start with. Okay, here we go. So information I have so far is tangent actually equals y over x. Okay, so I need to find out exactly what x equals and exactly what y equals. Now, I know my y is going to be an 8, and I know my x is going to be a 15, and somebody is negative because there's a negative sign hanging around. Who in quadrant 4 is negative, x or y? Y. Now I know you're probably thinking, well, Ms. Holcomb, the negative's on the 8, but you know how I put a negative on the top of everything, even if it's the bottom that's really negative. So it's always a good idea to check that. All right, how would I get r? It's my x squared plus y squared equals r squared. Let's see. And then if you take the square root, I got a nice little 17 for r. Okay. And then I'm going to come right over here. Okay. And I'm going to do 2, all right, times sine theta. Sine theta is y over r. So y over r. Cosine theta is x over r. I'm just plugging them right in. And then I came out with an ever so lovely negative 240 over 289. And that's going to be my answer. Okay, let's make sure we can get that in our calculator. So I'm going to have 2 times negative 8 over 17 times 15 over 17. And I get that crazy decimal. Then I do math, frac, and there it is. Okay. Everybody okay with that one? Okay. Let's see. What are we on now? Okay, let's do one last one and then we'll stop. Okay. And then we'll wait till Monday to do the rest. So let's look at 110. It'll be a good place to stop at the, oh, no, I'm sorry. We'll do 109. That'll be a nice place to stop. Okay, let's do 109. Actually, I think that one's going to be too long. Let's stop at 108. We'll just stop right there. Okay, because I forgot. We got to do a couple of different things.